These are the three engines I've decided to show this week. This one's a Nordic. It looks old, it's interesting. It's actually got two piston rings in there. I don't know how well the camera will pick it up, but there is two piston rings on that piston in there. Cast crankcase. It's got a carburetor on the back. It's got good compression, so I'm sure that one would run. I don't know what size it is, but it's quite a meaty looking affair. The next one is a little diesel, a Frog diesel. Quite a nice little engine. That's got bags of compression. No carburetor on these, just a little needle valve. Then this is actually one of my engines I bought at a car boot sale. It's an Olsen. It's actually spark ignition, as a magneto type affair, or some points go in the back and it runs off spark ignition. I've been told you can get an adapter, put a glow plug in and run it on glow fuel. I didn't pay a great lot for it, well, I'm sure it'll be quite a collectible little engine, that. I've got a nice little machining job to do here for a friend. It's what they call a lantern type tool holder, or a lantern type tool post for an old vintage lathe he's doing up. It's got a base 63mm wide. It's quite big. Total height is 190-200mm. The bolt through the top and the slot that the tool goes into. The body's 30mm wide. I've got a bit of 65mm bar. There's quite a bit of waste, but this one's been made out of the solid because it needs to be strong between these two. All the dimensions are there. I'll probably use 12mm bolt for that, because I've got some 12mm fully threaded bolts. Right, we'll get this bit of steel chucked up and get some metal ploughed off. There's quite a bit to come off, obviously, from 65 down to 30. Might even spend a little bit of time setting the lathe tail slot up, because there's that much to come off. We'll have plenty of opportunity to do some measuring of the diameter of the bar. This is the bit of material I've got. I don't know what it is, but it looks decent. It's nice when you put something in this chuck and it runs through. That's not bad at all. Just enough weight on there to support it, just nice like that, and you keep checking it, because as the job gets hot it will expand. You can hear the lathe working, but it's not struggling, it's just doing what it's supposed to do. Running at 200 RPM, taking nearly quarter inch off. That little Banggood insert certainly earned its money. bad finish actually for it. It's taken off. Same size at both ends, so it's doing pretty good. I've put a new tip in, it's running 1000 RPM now, and that's taking a half mil cut aside, which will take it down to 31, then one more cut, and take it down to the size I need. It's putting a really nice finish on, I'm very happy with that. I'm not sure what grade of steel it is, but it's certainly nice to machine. Right, this will be the last cut. Half into the side, that'll take down to 30. Pretty good. I need 1.5 mil off that diameter and touch it off. That's the 1 mil. Break that nasty sharp edge, put a little chamfer on it, like that, so it looks like somebody actually cares what they've been doing. Right, this end needs a taper turning on it, so I've set the compound side across and we'll have a little bit of experiment and see what sort of taper we're going to get. This serves no purpose other than it looks good. I'm going to make it a little bit shallower than that. The taper needs to be down to about there. There's no specific taper on the drone, so I can basically do whatever I think looks right. Bit shallower again. This is looking better. It's not a bad finish. I'm going to settle for that. Looks nice. There's a 14mm wide slot, gets machined down there. So I'm going to drill this and tap it into this end, 12mm by 175, because that's the bolt I've got. I'm also going to drill all the way through, tap and drill size, down to where the slot ends. Just so when I mill it out, it means the miller cut will break through into that hole. And it's going to help get shot of some of the chips and things. So we'll push this drill through. I've got some long series drills here. This is a long series 10.2mm drill, which is the tap and drill for 12 by 175. So I'll put this into full depth. And like I say, when I come to mill the slot, it's going to give us quite an advantage. Right, this is an M12 by 175 tap. Plenty threads into it. I'm going to put this machine tap in just to finish the threads off. The first tap was a taper tap. So we've got some nice sharp clean threads in the end of there. Just going to derag that hole and then put a little piercing pass across there. This means if it gets bumped, it won't damage the start of the thread. Right, so happy with that end. Next is to part it off. Fluid coolant would really help. I've got my hand on the clutch just in case. It was always a little bit nerve-wracking. But since I've tightened these headstock bearings up, I've had no problems at all parting off. That's run at 90 RPM. about there. And I'm going to finish off with a hacksaw because I don't want that dropping on my lathe. Right, that's 2mm to come off that face. I haven't got a fantastic grip on it because I don't want to mark it. So just gently ease this 2mm off. There's a 1mm cut, it should take that, no problem. See how versatile that little right hand knife tool is. Nearly all the machining on this has been, in fact all the machining apart from part loss been done with that tool. Yeah, I'm going to put a centre mark in there just in case I need it in the future. Sample on the same as I say, just to centre drill the end of that, and that's basically all the lathe work done. Quite a decent finish in there. It's obviously a bit of nice material I've used. So that's it. No empty tape, which is some usual for me. Once again, it's just time to say thanks for watching, thanks for subscribing, and as always a massive thanks for all the well wishes that have been coming in, especially towards me dad. Anyway, thanks for watching.